Good morning, children. So, today we continue with the lesson on earthquakes. So, just a brief recap of what earthquake actually is. Earthquake is the sudden shaking of the earth's crust due to some internal disturbance. And to explain that better, children, you can see in this slide, supposing you push your index fingers against one another. The harder you push, the greater is the energy stored. When both your fingers can't hold the energy anymore, it is then that your fingers slip with one going upwards and the other going downwards. So, earthquakes also occur in the same way when this slip happens to the two tectonic plates. So, in the last class, we had studied about the different types of earthquake waves. We had studied about the seismic focus and the epicenter. Seismic focus is the point of origin of the earthquake below the Earth's surface, and the epicenter, not seismic, the epicenter is the point which is vertically above the seismic focus on the surface of the earth. So today we will be studying about how the earthquake is measured. So, how the earthquake is measured? The seismograph, the Richter scale and the Mercalli scale are used for measuring the direction and intensity of earthquakes. Now first, the seismograph. This is the picture of a seismograph. The direction of movement of the waves, that is the seismic waves, and the passage at a particular point is recorded by an instrument called the seismograph. It has a pen attached to it, and the pen starts to vibrate with the earthquake waves recording their movement on a traveling strip of paper. It also calculates the difference in the arrival of P and S waves. This interval is then used to calculate the distance between the recording station and the epicenter. So children, in this slide you can see how the earthquake waves are recorded. The Richter scale has been named after the American seismologist Charles Francis Richter. It measures the energy released at the focus of a quake. So the Richter scale measures the power of an earthquake on a scale of 1 to 9. It measures the absolute intensity with mathematical precision. So on a 1 to 9 scale, a magnitude 7 quake is 10 times more powerful than a magnitude 6 quake, 100 times more powerful than a magnitude 5 quake, 1000 times more powerful than a magnitude 4 quake, and so on. The second type of scale is the Mercalli scale. The Italian seismologist Giuseppe Mercalli introduced the scale at the turn of the 20th century. It measures the intensity of shaking with gradations from 1 to 12. However, children, the Richter scale is most commonly used. So the Mercalli scale, children, because it is based on observed effects which may vary from region to region, so that is why it is generally not followed. The effects of earthquakes can be divided into two broad categories, the constructive effects and the destructive effects. Now, from the Earth's point of view, the earthquakes are constructive because they are a part of the endogenic forces which release the tremendous amount of energy which is stored up in the interior of the Earth. So, both volcanic eruptions and the earthquakes, they are regarded as good from the point of view of Earth because they release the immense amount of energy which is stored in the interior of the Earth, and thus they help to keep the Earth in good shape. The second effect of the constructive effects is that they help in creating landforms. Because of vertical and lateral displacement of the Earth's crust, the earthquakes may raise or lower parts of the Earth, especially near the seashore. For example, the Sagami Bay of Japan was uplifted 200 meters in 1923. The landslides which are triggered by earthquakes may result in the formation of lakes, as it happened in the Himalayan region. Now let us see what are the destructive effects of volcanoes. As I already told you that from the point of view of Earth, the earthquakes are good because they release the immense amount of energy which is there in the interior. But from the point of view of human beings, the earthquakes are very destructive because they result in immense loss of life and property. People get buried under buildings, the roads break, the buildings break, then the earthquakes trigger landslides, avalanches. You know what are avalanches? Avalanches are when huge mass of ice and snow starts to slide down in the mountainous areas. That is an avalanche. So this is a major environmental hazard to these areas. So children, in this slide you can see the picture of a landslide which has taken place. Now when the earthquakes takes place, the earthquakes destabilize the loose rocks which lead to landslides. So this damages the buildings and it disturbs the transport system, as you can see in this picture very clearly. The next effect is that in the past, earthquakes have changed the course of the rivers and thus they have rendered many areas unsuitable for irrigation and agriculture, especially in those areas which were densely populated. When the rivers changed their course, then that area got flooded underwater and this resulted in flooding, loss of life and property again. Now, during an earthquake, fires break out due to inflammable material thrown out, broken glass, gas pipes, and bursting of gas cylinders. Damaged oil refineries, live electric wires catch fire and damage life and property in townships in the factory complexes. Another effect is the tsunami. A tsunami is a large destructive ocean wave that can be generated by any disturbance that rapidly displaces a large mass of water, such as an earthquake, volcanic eruption, landslide, or a meteorite impact. So the most common cause is the undersea earthquake, meaning when the oceanic crust, when there is an earthquake of the oceanic crust, then it displaces the water, producing huge sea waves, as you can see in the picture. Like imagine if you take a tub of water and you start shaking it vigorously, you will see that the water starts to get displaced. So in the same way, when the oceanic crust starts to shake because of an earthquake, then the water above, the sea water, huge sea waves are created. So the name tsunami is from a Japanese word su and nami, meaning harbor wave. So tsunamis are actually harbor waves and they are very common, especially in Japan. So it had also occurred in the Indian Ocean. So these tsunamis, again, like earthquakes, they produce, in 2004 in the Indian Ocean, there was a series of severe tsunamis on December 26, 2004, making it one of the deadliest tsunami in the recorded history. Similarly, in 2011, there was a tsunami in Japan. So these tsunamis, children, they result in immense loss of life and property. The next impact of earthquake is flash floods. Often due to earthquake, the dams and embankments, they get damaged. So the enormous amount of water, gallons and gallons of water which is stored in the reservoir, that starts to flow and it starts to flow speedily, resulting in flash floods. Now besides this, the debris which is produced during the earthquake blocks the flow of the river. The river flow gets diverted from its original course. This diversion again causes flash floods and again loss of life and property. Now let us see the major earthquake zones. Again, as I had told you in the chapter of volcanoes, the belt of earthquakes and volcanoes are roughly the same. So most earthquakes originate from plate boundaries in the regions where an ocean plate and the land plate converge, submarine ridges are formed. The underlying rocks are unstable and they are subjected to movement. Any movement triggers earthquake in the continental areas. So there are three main belts: the Circum-Pacific Mountain Belt, which has 70% of all the earthquakes. A part of the San Andreas Fault in USA lies in this belt. The fault zone makes California and USA highly susceptible to earthquakes. The area of Japan, Philippines and Indonesia all form parts of this belt, and they are prone to severe earthquakes as well as tsunamis. The second is the Mid-World Mountain Belt. It stretches from Eastern Europe, covering alpine Himalayan ranges in Europe and Asia, as you can see in the map. Alright, you can see that in the map. About 20% of all earthquakes occur in this zone. The third is the Mid-Atlantic Ridge. You can see in the Atlantic Ocean where it's written Mid-Ocean Ridge. So this belt comprises areas along the mid-oceanic ridges as well as many islands near the ridges of Atlantic Ocean, and the remaining 10% of the earthquakes occur in this belt. In this ridge, two tectonic plates move in opposite direction. Some moderate earthquakes are recorded along the ridge. The Rift Valley, the Great Rift Valley of East Africa, is considered as an extension of this belt. Now let us see two examples of Indian earthquakes. The first one in the year 2011, it took place in the state of Sikkim. So this is mainly because of the movement of the Indian plate towards the Eurasian plate at a rate of 5 centimeters. So this earthquake was, it resulted in tremendous loss of life and property. And this plate movement also has been responsible for the earthquake in Nepal. The second example, children, it took place on 26 January 2001 on Republic Day. A lot of children died during this because they had gone to the school. So the earthquake was felt as far away as Delhi. Bhuj town was the worst affected and the area surrounding it. So this was the earthquake again. Predicting earthquakes accurately is the goal of many seismologists across the world. But the ability to predict when and where the earthquakes will occur still remains limited, even though we have made so many advances in science and technology. So children, the Russians were the first to discover P&S seismic waves during 1960s, and on the basis of this, predictions were made. These waves still are the only means available to seismologists to predict earthquakes. The next is the theory of plate tectonics. This is another means of prediction on scientific lines. The Japanese use the method of measuring changes in the sea level and variations in the Earth's magnetic field to predict earthquake. Sometimes the scientists say that the animals start to behave abnormally before the arrival of the earthquake. Sometimes there's a slight change in the tilt of the Earth's surface which can be detected. However, children, no method is still foolproof, as has been proved by many earthquakes where many countries were caught unawares. Even though lot of advancement has been made in science and technology, children, it is very, very difficult to predict nature. So predicting earthquakes still is a big challenge.